Hello and welcome back. It's time for another fantastic Algebra 2 lesson. Today, we will be talking about solving radical equations and inequalities. So the goal with solving radical equations and inequalities is to basically eliminate the radical that's there. But before we can do that, the first thing we have to do is we have to isolate the radical. So in this particular problem, you can see we have a 2. We have a 2 in the beginning of the problem. So 2 times the square root of x plus 2 equals 8. So what we want to do is we want to get rid of this 2 first. And the best way to get rid of the 2 is to undo the operation that's right in here between the radical and the number. And that operation is always multiplication. So what we're going to do in order to solve this problem, when we start off solving the problem, what we're going to do is we're going to divide both sides by 2. By dividing both sides by 2, we will isolate the radical. We'll get x plus 2 equals, and we'll do 8 divided by 2, and we'll get 4. Now it's pretty straightforward. We have to get rid of the radical, and the way we undo a square root is by squaring both sides. Pretty straightforward. The square root of x plus 2 squared, the squared and the square root will cancel each other out. So we're left with x equals 2, and 4 squared is 16. One more step. Go ahead and subtract 2 from both sides. We end up with the answer of x equals 14. Now, folks, it's a really good idea that we get in the habit of checking our answer to make sure that the answer we get here works. Radicals can kind of be a little weird sometimes. We can get some things underneath radicals, and we can get equations that don't necessarily work out when we plug our answers back in. We'll talk about that soon. In this particular problem, we'll have 2 square root of x, but x is 14 we found. So the square root of 14 plus 2 equals 8. So let's see here, 2, the square root of 14 plus 2 is 16. So we have 2 times the square root of 16. The square root of 16 is 4. So we have 2 times 4, and 2 times 4, of course, equals 8. So we can be very confident that our answer over here of x equals 14 is, in fact, the solution to this equation. Let's try another one. In this particular problem, we have the third root of the quantity 2x minus 5 minus 2 equals 3. And we're going to do the same idea here. We're going to eliminate, or I'm sorry, we're going to isolate the radical. So that means getting rid of the minus 2. So we'll add 2 to both sides. That's here. That gives me the third root of 2x minus 5 equals 3 plus 2 is 5. All right. Now we're going to undo this radical. Well, it's not a square root, it's a third root. And the best way to eliminate a third root is to raise it to the third power. See, the third root and the third power kind of cancel each other out, and I'm left with just 2x minus 5. 5 to the third power is 125. Wow, that's a big number. So now we're left with a very easy equation to solve. So we'll add 5 to both sides. We'll end up with 2x equals 130. We'll divide by 2. And we'll come up with x equals 65. Okay, so let's check this answer real quick. Let's do a little check over here. So we'll check x equals 65. We got the third root of 2 times 65 minus 5. That quantity minus 2 equals 3. Let's hear. 2 times 65 is 130. Minus 5 minus 2 equals 3. 130 minus 5 is 125. So we have the third root of 125 minus 2. Third root of 125 is 5. And 5 minus 2 does, in fact, equal 3. So again, we can be confident that x equals 65 is the right answer. So here are 3 problems. What I'd like you to do is to pause the video right now. Why don't you give these 3 problems a try? I'm going to work them out on the following slides, as I always do. So go ahead and pause the video, try these 3 out. I don't think you have any trouble. All right, so for this problem, we're going to isolate the radical. We're going to isolate the third root of x minus 9 equals 6. So we'll add 9 to both sides. Let's see here. So that gives us the third root of x equals negative 6 plus 9 is 3. And then we'll raise both sides to the third power. And we'll get x equals 3 to the third power is, of course, 27. Let's check that real quick. The third root of 27 minus 9, does that equal negative 6? This third root of 27 is 3. 3 minus 9 does, in fact, equal negative 6. That's a quick check. So x equals 27 is my answer. Problem number 2, the square root of x plus 25 equals 2. Oh, nothing to move here. The radical's already by itself, so I'm going to start off just by squaring both sides. That gives me x plus 25 equals 2 squared. 2 squared is 4. And I'll subtract 25 from both sides, and I'll get x equals negative 21. Let's check it real quick in the problem. The square root of negative 21 plus 25, does that in fact equal 2? Negative 21 plus 25 is 4, and the square root of 4 is in fact 2. I can be confident my answer, x equals negative 21, is correct. Finally, number 3, 2 times the third root of x minus 3 equals 4. I'm going to isolate the radical. To isolate the radical, divide both sides by 2. That'll leave me the third root of x minus 3. 4 divided by 2 is 2. I'll now raise both sides to the third power, and I'll get x minus 3 equals 2 to the third is 8. Finally, I'll add 3, come up with my answer of x equals 11. Let's check it. 2 times the third root of 11 minus 3. Does that equal 4? That's here. 11 minus 3 is 8. The third root of 8 is 2. And I end up with 2 times 2, which does in fact equal 4. Yes. So x equals 11 is my final answer. All right, so we're going to switch gears a little bit here. We have the square root of 2x plus 7 equals x minus 4. And you might notice something here. You might notice that we have an x that's underneath of the radical and an x that is not underneath of a radical. That 2x is underneath, the x on the other side of the equation isn't. So we really can't do anything to combine these two x's together. This 2x that's underneath the radical cannot be combined with this x that is outside of the radical. That's not allowed. That breaks rules of mathematics, and there's no math that will allow me to do that. So what I'm going to do is I'm going to still kind of go through the process like I did before. What you want to do is you want to isolate a radical, get a radical on the side by itself. And then we're going to eliminate that radical. So in this particular problem, you'll see that the square root of 2x plus 7 is on a side by itself. We're going to undo that square root. So how do we do that? We square both sides. Now, on the left-hand side of this equation, that's easy. The squared and the square root cancel out. I'm left with 2x plus 7. But on the right-hand side of the equation, we have to be very careful. We have x minus 4 squared. Please make sure you remember that that means x minus 4 times x minus 4. So even though it doesn't look like it, you actually have to FOIL out that binomial on the right-hand side. We get x squared minus 8x plus 16. That is the most common mistake, is forgetting to multiply that out the right way. So make sure you don't. Now, if you look at this step, we have 2x plus 7 equals x squared minus 8x plus 16. Ooh, this on the left-hand side is a quadratic type equation. So we need to solve this like we did all of the other quadratic equations that we've done in the past. What we want to do is we want to set this equation equal to 0 and solve. So we want to set the equation equal to 0 and solve. In order to do that, we'll subtract 2x from both sides. And we'll subtract 7 from both sides. So let's see here, that gives me 0 equals x squared minus 10x. 16 minus 7 is 9. And now we're left with the quadratic equation, 0 equals x squared minus 10x plus 9. All right, so let's see here. How do I solve that quadratic equation? Well, I have two options. I always have two options, either the quadratic formula or factoring. I'm going to pick factoring when I can, and this particular quadratic equation is in fact factorable. X minus 9, x minus 1. Again, we're looking for the pair of numbers that multiplies together to give me 9, but adds together to give me negative 10. Okay, and that is negative 9 and negative 1. So this factors down to be x minus 9 times x minus 1. Just like before, I set each one of those factors equal to 0 and solve them individually, and I get x equals 9 and x equals 1. It is extremely important, and I can't stress this enough, especially when you have variables on both sides of the equation, one outside the radical and one underneath the radical. We need to check these solutions. I cannot emphasize that enough. So let's check x equals 9 and see what happens. The square root of 2 times 9 plus 7 equals 9 minus 4. Notice we plugged x in for both, or 9 in for both of the x's. Let's see, on the left-hand side, 2 times 9 is 18. So we have 18 plus 7, 9 minus 4 is 5. and we have the square root of 25 equals 5. That's good. That's right. All right, so let's try the other guy. Let's try x equals 1. Let's check that one. So that's the square root of 2 times 1 plus 7 equals 1 minus 4. 1 minus 4 is negative 3. And let's see here, I get 2 plus 7, and that gives me the square root of 9. Ooh, the square root of 9 does not equal negative 3, it equals positive 3. So this guy right here, the x equals 1, is not a solution because it did not give me a true statement at the end. So this x equals 1 is not a solution. The only solution is x equals 9. So this guy right down here, this x equals 1, is something called an extraneous. Let me write that out. Extraneous solution. Extraneous solutions are answers that we get when we solve the equation algebraically, but do not ultimately work in the original problem. Extraneous, think of the word extra, extra solution. Okay, so think of it that way, and it might help you to remember extraneous solutions. So again, we have to be on the lookout for those when we do these problems. So here are 3 problems, and again, like we did last time, I'd like you to pause the video right now. I'd like you to try these 3 problems, and again, do not forget to check for extraneous solutions when you work through the problems. I'm going to show you the solutions here coming up, but try these first on your own. All right, here's the first problem. The square root of 10x plus 9 equals x plus 3. All right, radical's already on a side by itself, so I'm going to start off right out of the gate by squaring both sides. I get 10x plus 9 equals, let's hear, this is x plus 3 squared, which is x plus 3 times x plus 3. If I want to write that out so that I don't forget to FOIL it, that gives me x squared plus 6x plus 9 over there on the left-hand side. I still got the 10x plus, I'm sorry, on the right-hand side. I still have the 10x plus 9 here on the left. I'll combine my like terms, set this thing equal to 0. So I'll subtract 10x and subtract 9 from both sides. That gives me 0 equals x squared minus 4x. Hey, this is pretty cool. Now don't forget, this is like the easiest factoring there is. So I'm going to just factor out the GCF of x. That gives me x times x minus 4 over there on the right-hand side. I'll set each factor equal to 0, solve them individually, and that gives me 0 and 4 as my possible answers. I'll check them real quick. So let's go over here and let's check. Let's check x equals 0 first. So that's here. That's 10 times 0 plus 9. Does that equal 0 plus 3? Let's hear. 10 times 0 is 0, so I'm left with just the square root of 9. That does, in fact, equal 3. So 0 is a solution. Okay, let's check out x equals 4, see if I get the same thing. So here, 10 times 4 plus 9 equals 4 plus 3. 4 plus 3 is 7. Let's see here, 10 times 4 is 40. So I get 40 plus 9, which gives me the square root of 49 on the left-hand side equals 7 on the right. That is, in fact, true. So here we have a case where both answers work, no extraneous solutions. Number 5, the square root of 2x plus 5 equals the square root of x plus 7. Cool. 2 radicals on the same side, and I know that I can just square both sides and check it out. I eliminate both radicals in one step. That's really cool. And then it's just a basic algebra problem. Combine my like terms. I'll subtract x from both sides. I'll subtract 5 from both sides. And that gets me x equals 2. I should check it just real quick. Make sure nothing crazy is going on here. So let's see here. The square root of 2 times 2 plus 5 equals the square root of 2 plus 7. 2 times 2 is 4. 2 plus 7 is 9. See here, 4 plus 5, so I get the square root of 9 equals the square root of 9. Very true statement. Excellent. Last one, square root of 7x plus 15 minus x equals 1. Okay, I got to shift some things around here. I have to add x to both sides. I got to isolate the radical. Isolate the radical before I can eliminate it. So I get the square root of 7x plus 15 equals x plus 1. Now I can square both sides. Okay. Don't forget to FOIL on the right. So I get x squared plus 2x plus 1. On the left, the radical and the squared cancel each other out. I get 7x plus 15. I'll subtract 7x. I'll subtract 15. I'll get this quadratic set equal to 0 when I do that. So I got x squared minus 5x minus 14 equals 0. Again, this is a quadratic. I can solve this using the quadratic formula or by factoring. This is nice and factorable. I get x minus 7 times x plus 2, and I come up with two solutions, 7 and negative 2. I'm going to check them quick. So let's do the check. X equals 7. So that's the square root of 7 times 7 plus 15 equals, minus 7 equals 1. So that's 49 plus 15 underneath the radical. And let's see here, 49 plus 15, 64. So I have the square root of 64 minus 7. Square root of 64 is 8. 8 minus 7 equals 1. And 1 does equal 1. That guy works. Okay, I did not leave myself enough room. Let's do that again and try negative 2 for my answer. So let's try negative 2. We'll check negative 2. So I have 7 times negative 2 plus 15 minus 7. Let's hear. That's the square root of negative 14 plus 15 minus 7. This negative 14 plus 15 is 1. And I end up with 1 minus 7. Oh, that does not equal 1. So negative 2 here is not a solution. That is my extraneous guy. The only solution is x equals 7. Hope you guys found this video helpful. If you have any questions, please let me know. Good luck on your homework.